Hello everyone, I am Madhushri B. I am studying first year MSc in JSS College UT Road. My seminar topic is solvent extraction. First I will discussing about what is separation. Separation is a method that converts a mixture of chemical substances into two or more distinct product mixture. In the separation, the result is to retrieve at least one of the interested constituents, may fully divide the mixture into fewer constituents, purification or to remove interferences. The basis is differences is chemical or physical properties such as size, shape, mass, density or chemical affinity between the constituents of a mixture. Separation of compounds from different systems. There are two types of mixtures, solid in liquid mixtures and liquid in liquid mixtures. Solid in liquid mixture, there are two types, homogeneous mixtures and heterogeneous mixtures. Homogeneous mixtures are separated by evaporation, distillation and centrifugation method. Heterogeneous mixtures are separated by sedimentation or gravitation method, filtration method, magnetic separation and fractional distillation method. In liquid mixture, there are two types of mixture, homogeneous mixtures and heterogeneous mixture. Homogeneous mixture are separated by simple or fractional distillation and chromatographic method and electrophoresis method. Heterogeneous mixture are separated by partition by separation using funnel. In quality aspect of finished product is very significant in mining industry, food processing laboratories or industries, synthetic laboratories and or in research centers. Family tree of separation techniques. In separation technique there are two types of techniques, non-chromatographic and chromatographic. In non-chromatographic method, extraction and electrophoresis method, and in extraction method, liquid and liquid extraction, supercritical fluid extraction, solid phase extraction. And in chromatographic method there are two types, column and planar. In column chromatographic, gas chromatography and liquid chromatography and supercritical fluid chromatography. In planar chromatography, PC and TLC. In this I will discussing about what is solvent extraction. Solvent extraction is a process in which compounds are separated based on their relative solubilities. In this solvent extraction we take example of separation of benzoic acid and para-methoxyphenol. The requirements are solvents and separating funnel, mixer in CH2Cl2 in separating funnel, add saturated sodium bicarbonate solution, shake separating funnel and equilibrate. In solvent extraction, I take the example of separation of benzoic acid in para-methoxyphenol. The requirements I need that simple extraction funnel. It may be 125 or 250 ml separated flask. A clean separation flask is required. You take the mixture of benzoic acid, para-methoxyphenol. You dissolve that in dichloromethane. Both are soluble in CH2Cl2. When you take the solution in separation funnel, you add aqueous saturated solution of NaHCO3. This is sodium bicarbonate to the separation flask. First in the step, you dissolve both the compounds. You dissolve the given mixture in dichloromethane. Then you transfer the solution into separation flask. Then in the next step you have to add saturated sodium bicarbonate solution to the separation flask. Benzoic acid and para-methoxyphenol both are present in the mixture. You have made this saturated sodium bicarbonate to interact with these two compounds. So after the addition of saturated sodium bicarbonate solution, you will close the stopper to the separation flask and you will shake the separation flask regularly at 30 seconds or 60 seconds. Once the shaking is over, you will make the separation flask starting. You will keep it as such, so you will allow the layers to equilibrate because dichloromethane and aqueous sodium bicarbonate layer are invisible because this is going to aqueous, this is going to be organic. Dichloromethane is organic solvent. Saturated sodium bicarbonate is aqueous in nature. So both are them are immiscible. So when you keep the separation flask in equilibrium process, you will able to see two layers. This is the first factor. Second thing is because benzoic acid is strong acid than paramethoxyphenol, the carboxylic acid of benzoic acid will be made to react with sodium bicarbonate is weak base. So benzoic acid is used to be reacting with sodium bicarbonate to undergo neutralization reaction. Simple acid base reaction takes places. As a result, benzoic acid is converted into sodium benzoate. Sodium benzoate is easily soluble in water because water is used to prepare the saturated solution of sodium bicarbonate. So initially benzoic acid is present in dichloromethane. Layers after the treatment of this mixture with sodium bicarbonate, benzoic acid has been converted into sodium benzoate and its soluble in dichloromethane. Its declared solubility of water has been increased, therefore it will come to the aqueous layer. Now as a result in paramethoxyphenol, as a result its separation is as liquid extraction. Therefore solvent extraction is a process in which selective transfer of solid from one liquid phase to another liquid phase based on their relative solubilities is involved. In solvent extraction, aqueous solvents are taken as pure water and acidic pH 0 to 6 range and basic pH 8 to 14 range and ionic strength solutions, complexing agents and ion pairing agents and chiral reagents. And also in solvent extraction, organic solvents are taken as chlorinated solvents and hydrocarbons, aliphatics, C5-pentane and above, aromatics, toluene and xylene, alcohols and esters and ketones, C6 and above, ethers, diethyl and above. And also in solvent extraction, selectivity of separation depends on in aqueous solvents purity, even modifiers too with adequate purity. During dissolution, analyte has to be made less hydrophilic and more hydrophobic. In solvent extraction, selectivity of separation depends on in organic phase immiscibility, density, volatility, toxicity, polarity and cost. In this I will discussing about theory of solvent extraction. In theory of solvent extraction, sometimes is called liquid extraction, involves the selective transfer of substance from one liquid phase to another. Usually an aqueous solution of the sample is extracted with an immiscible organic solvent. For example, if an aqueous solution of iodine and sodium chloride is taken with carbon tetrachloride and the liquids allowed to separate, most of the iodine will be transferred to the carbon tetrachloride layer whilst the sodium chloride will remain in the aqueous layer. The extraction of solute of in this manner is governed by the next partition or partition law, which states that at equilibrium a given solid will always be distributed between two essentially immiscible liquids in the same proportions. Thus for solute A distributing between an aqueous and organic solvents, the equation is A concentration of A organic divided